Hello, folks. Welcome to Rational Science. Been sick these last 2 weeks, little over 2 weeks. Beginning of this past week, I was 3 days in the hospital. In fact, I still have my wristband just in case I have to return. Let me turn my phone off so that I don't get interrupted here. There we go. Anyways, was in the hospital, erysipelas. My leg gets infected with bacteria and gets all red. And I was in intravenous penicillin, and now I'm on pills. And again, I keep this on just in case I got to go back. But hopefully it's getting better. Anyways, let's get on to the subject matter of today. And there's a word of caution before we get into the subject matter. And the word of caution is, you may lose a few points on your IQ level if you stick around. So my strong recommendation is that right now you leave the channel and don't watch the show today. Okay. What are we going to talk about? Well, we're going to talk about this thing called simulation theory. They call it a hypothesis. It's not a hypothesis. It's a theory. It's an explanation. According to this theory, this explanation, this physical interpretation, we were made. What you are is a computer simulation run by an advanced civilization. I suppose they look something like this. Okay, let me give you something to look at. I guess that's you there. One of the questions you should ask yourself as we go through the lecture today is whether where does this happen? I mean, is this out there in space or is this in a computer? Another one is, when did this start? I mean, are we talking about it started with you, with me, with this generation? Or are we talking about, my great-granddaddy, Adam? Is that when it started? They created Adam and then the whole thing started after that? Just kept rolling? Because otherwise they have a contradiction. On the one hand, they defend evolution, and on the other one, they said, look, we were made by a computer, by an advanced civilization in a computer program of some kind. So, again, we have a problem there. We have to decide, who was it that they made? Did they make Adam or did they make you, right? And there are questions of that nature. There's another issue of, there's a confluence of determinism and free will. People have always fought back and forth. Do we have determinism in the universe? Is everything just deterministic, or is there free will? And so you ask any human, more or less, people will say, yeah, I have free will. I can do anything I want. But see, these people are suggesting or insinuating, with their theory, that the extraterrestrials that made us, the aliens, they already made you think that you have free will. And part of it that's behind this theory that you have to keep in mind at all times is this nonsense about the black universe. God sees the whole universe, past, present, and future, in a single go. And so the question is, once again, if the future already exists, do you have free will? Or are you just a cartoon character in a movie? It's like Bugs Bunny. Can he do something different than what the script writer and the person who draws the cartoon, can he do something different than what they specified for him? Be scary, quite a bit scary. And that's more or less the situation here. So where did all this nonsense start about, because what else can you call it? Yeah, it is nonsense. It's called this simulation. It started with this fellow. He proposed it in really in 2001, and he really published it in 2003. And the question is, what peer reviewers approved this? One issue, and then why are we still talking about this today? There are other papers being written about this stuff, so it hasn't stopped. Okay, so here it is. It's this fellow, his name is Nick Bostrom, and he says this paper argues, this is his groundbreaking paper, right? This paper argues that at least one of the following propositions is true. The first one is, the human species is very likely to go extinct before reaching a post-human stage. And the answer is, well, he's close, but not quite. I mean, it's guaranteed to go extinct before the post-human stage. Okay, but I guess he didn't figure that out. He said it's very likely, right? Okay, and so what's part of the problem with this? Well, first we need to know what this post-human thingy is. What is that? Post-humanism. What is that? What is he talking about? And here it is. Post-humanism, there are several issues involved with that. I put the main ones, the ones that I think concern at least this lecture. One is transhumanism. And it says develop technologies that enable immortality. That's what these people have in mind. Live forever, right? The dream that we've had since day one, since we, gained consciousness. And that greatly enhance human intellectual, physical, and psychological capacities in order to achieve what? A post-human future. So post-human means that you're no longer going to be human. You're going to be something else, I guess. Then there are these other issues, the AI takeover, artificial intelligence, right? Humans will be replaced by artificial intelligence. Technological singularity, this is what they hope to achieve, after which technology will advance exponentially, right? It says humans should get ready to accept their eventual demise and be replaced by bots, right? And together with that, you have this cosmism. We should develop artificial intelligence, even if it may entail the end of humanity, for it would be a cosmic tragedy if humanity freezes evolution at the puny human level. Also known as voluntary human extinction. In other words, we know we're going to become extinct. Why? Because it's the bots who are going to replace us. And the question is, do we still have humans on Earth? Or have the bots taken over and we run the Earth first and then the whole universe with bots? Is that the future of intelligence, of evolution? We evolve into, not physically, but we evolve culturally and through technology into bots. That's what these people are suggesting. But that's the negative side. Humans become extinct. There's a positive side. There's these people who are optimists, and one of them is this fellow, another bean brain. His name is Ray Kurzweil, and he says the following. He says, technological progress follows a pattern of exponential growth, following what he calls the law of accelerating returns. In other words, he thinks that technologies will just blow the field wide open, that right now we're going at a snail's pace, but once we reach that singularity, when the bots take over, hey man, the sky's the limit, right? And it's going to be exponential, right? The development of technology. Whenever technology approaches a barrier, new technologies will surmount it. This is what he's got in the back of his mind. This is what he thinks he just extrapolates the past to the future indiscriminately without really, putting any mental capacity, any mental resources to the problem. He just extrapolates the numbers, what he's seen in the past. And he said paradigm shifts will become increasingly common, leading to a technological change so rapid and profound it represents a rupture in the fabric of human history. Okay, this is what he's predicting. Got little birdies around his head. Should have put one of those astrologer cones on his head. They predict all this stuff, right? Palm readers. We used to call them astrologers. Now they're called futurists or futurologists or whatever they call themselves. The technological singularity will occur by approximately 2045. So get ready, okay? And he thinks it's going to be a gradual ascent. Others think it's going to be much faster. And progress in science and technology will lead to an abundance of what? Virtually free resources, okay? Enabling every citizen to live without the need to work. So he is an optimist, no doubt about it. He says that humans will continue living, but what's the situation? Situation is that, these people say the bots are going to be our servants. They're going to serve us forever and ever, and we're just going to do nothing. All the work's going to be done by them. Talk about slavery. I mean, we're not talking about building a pyramid here. We're talking about, everything in your house being done by robots, and you're going to be, a vegetable maybe? And not even an incentive to learn or to better yourself, because you can get all that information at the tip of your fingers, so. Well, what this fellow's missing is the technological curve, which more or less looks like this, okay? You can see all technology always reaches a plateau. It's asymptotic in growth, and then it goes down. You can make improvements on existing ideas that are out there, existing inventions, and improve them. You can make it red instead of blue, great. So you have a new invention because it's a red refrigerator instead of a blue one. Any change to an existing gadget is already patentable, I guess, and it's a new invention according to the patent office, okay? But yeah, the issue is that not only do each individual technology, does an individual technology reach a plateau and then starts falling down, but that's not only in technologically true, but it's also economically true. You have this plateau and then starts coming down. But the issue is whether technology will continue advancing. Forget about exponentially. I mean, even arithmetically. Is this true? Will technology go on forever? And what these people don't realize is the first thing is that we're through with technology. There is no more technology. We're done with technology. We've been done with technology some years back. We've got everything we need as far as technology is concerned. The ultimate prize was getting this, this phone, a portable phone that has everything in it, computer. You can talk to your mother on the other side of the planet. You can look up things. It's the all-in-one computer, typewriter, telephone, television, the whole thing, all in one. And that was the ultimate goal. And it's not really an invention. It's putting together several inventions, the TV, the radio, the phone, etc. All they did was put it all in one. They say, well, here's an invention. Well, it's not really an invention. It's putting all these ideas together and creating the device we always craved, which is the all-in-one portable whatever you want to call it, smartphone, okay. That's it. That was the last, you can say, invention of any worth that we really wanted. What else do we need? What else do we want? And it's going to take you a while to figure something that you really, really want. And I don't want you to think of one thing. I want you to think of 1,000 things that you want. And you certainly won't come up with them, okay? The age of manufacturing stopped in the 20th century, pretty much. And that's when technology was expanding. We were inventing things because everybody needed. We needed washing machines. We needed airplanes. We needed furniture. We needed so many things. And so a lot of people put their heads together and they started building all these companies that built all these gadgets. Let's call them gadgets. And they invented things in the process and made old things better, etc. But we're done with that process. The age of manufacturing is dead now. Only 15% is manufacturing, and that's what technology was supposedly for. Now the technology is geared to abstractions, programming. What do we program today? Games? Oh man, that's going to drive technology, through the roof. Games. What do we do? Just create more games? I mean, what else is there? technology. Certainly not anything tangible. It's going to have to be abstract, like, programming, internet, that kind of stuff. And so, yeah, the age of technological, meaning, when I say technology, I mean really manufacturing, solid things, right? That's over. And so to believe that there's going to be a point known as a singularity from which new inventions, physical inventions, gadgets, expand exponentially, what are they going to invent? Can you even dream or even imagine the billions of objects that we need that we never had? I mean, what are these people talking about? And this is a big part of the problem, the fact that they're extrapolating the past without considering the fact that, technology is over, and so is manufacturing. Now we're in the service area, region, age, and it's all abstractions, all internet. And so if there's any technological advancement, it's going to be all abstraction, nothing tangible. And so these people are talking about, things in medicine, that we're going to invent so many things that it's going to allow us to live forever. That's where they see the future, in just health, and especially, anything that gives us eternity. These people are dreaming. These people don't even know what they're talking about anymore. That's the reality. Okay, so this is the second thing that Bostrom said, good old Nick here, and he says the following. He says, any post-human civilization extremely unlikely to run a significant number of simulations of their evolutionary history. And so one of the questions there is whether, are we talking about, where's this taking place? Here I'm going to put a little image that will contrast, which of the two they're really referring to. Are they referring to the one on the left or the one on the right? The one on the left is a video game, you could say, some program in a computer, and you're in that program somehow, right? Or are we talking about, terraforming a planet like, Mars, and saying, look, we're going to terraform the aliens, right? They terraform and they put Adam in there or whoever, right? And evolution starts taking place. I mean, which of these two scenarios are they talking about? Are they saying, well, you're just a computer program? You're a cartoon like Bugs Bunny, a two-dimensional cartoon? Is that what they're saying? You're just some kind of signal in a computer system? Is that what you are? Or are we talking about them terraforming a planet? So we have to distinguish between these two scenarios. Are we saying that the aliens went to a planet, an existing planet, or maybe even created the planet and started playing around and creating life on that planet? Or are we talking just a computer program? And these people really are referring to the computer program because they don't really talk about, terraforming and real people. They're saying, look, you're like a computer program like Bugs Bunny, but suddenly, you start doing all these things, you move around, you think you have free will, but it turns out it's all deterministic because, again, the aliens already programmed everything in you, and on top of that, we have, unfortunately, the block universe that says the future already exists, and all you're doing is walking on footprints, existing footprints, and you can't avoid it. But you're saying, oh, no, I have free will, but you're being fooled. No, you don't have. It's kind of like this, more or less, here, what they're suggesting, like the Wicked Witch of the West, in The Wizard of Oz, looks at her crystal ball and sees, Dorothy and the others over there, right? I mean, these people have a surrealistic vision of the future, and they don't see anything wrong with it. They think this is normal, this is fair game. And the question is, how did this stuff end up in science? I mean, if you want to take it to Hollywood, I have no problem. Write a script, write a novel, turn it into a movie, no problem whatsoever. How did this garbage, this poppycock, this nonsense end up being treated in science? People writing papers, publishing papers, having peer reviewers approve it for publication. That's where my question is. Okay, how did this end up in science? And people say, well, it ended up in philosophy. no such monster as philosophy because no one has defined philosophy. Stanford Encyclopedia of Philosophy famously never defined the word philosophy. So you wonder what the Stanford Encyclopedia of Philosophy is about if they never defined the word philosophy. And you go to other sites which I've gone to, and they have all these irrational definitions. All they have is theories of what philosophy is. You had people like Wittgenstein and Russell and all these people discuss what is philosophy, and they ended up with analyzing propositions, which is what they called philosophy. If philosophy is simply a way of thinking, we have 8 billion philosophers on the planet today, and who knows how many throughout history. Everybody was a philosopher because everybody has a way of thinking. If the guy goes to the university and studies, and he says, I studied philosophy, I got a degree in philosophy, well, what's your degree in? Love of wisdom? Is that what your degree is in? We define philosophy as one of the branches of science, opposite to physics. Physics deals with objects, and philosophy deals with concepts. Has to do with purposes and reasons, and nothing but. That's it. That's the only piece of philosophy that survives, and it falls under science. So these people are bringing all this stuff into science really because they're not really bringing it into philosophy. They're bringing it under physics. They're saying there's a physical process where you are a cartoon character in a movie or in a screen or in some computer program, and look, I'm moving around, I touch myself. Yeah, you think you are, but you have been programmed by someone out there. So that's physics. That's got nothing to do with philosophy. You're talking about physics. You're talking about physical entities, right? And the only philosophical stuff is what you're thinking about, the mind-body problem, and I'll get to that in a minute. But other than that, you're talking about physics. So yeah, this if they put it under philosophy, it's in the wrong place. This should be under physics, and it should never have made it to physics in the first place, period. Okay, and what's the third thing this fellow Bostrom says? Well, he says the last one is, we are almost certainly living in a computer simulation. Okay, that's his conclusion. Why? It follows that the belief that there is a significant chance that we will one day become posthumans who run ancestor simulations is false, unless we are currently living in a simulation. My God, my poor God, what a brain this person has. What's this guy doing teaching at universities? Should be in a mental asylum. This guy has no ability to think whatsoever. And the wonder is that these people become celebrities. These people become big names, Kurzweil and Bostrom and so on. They win prizes and who knows what. So this is how he justifies it, more or less. He says, many works of science fiction, as well as some forecasts by serious technologies and futurologists. We're talking about serious people, okay, here. These are serious futurologists. They used to be called astrologers, palm readers, but now they're serious futurologists. Predict that enormous amounts of computing power will be available in the future. Okay, so these people are, again, extrapolating stuff out there, and they think that this computer power will just reach unbelievable limits, whatever that means in their minds. They see infinity and all these things, right? And because of that computer power, right, we should be able to simulate real living entities on a screen or in the universe. I don't know where, because again, these people don't specify what the platform is. Are we talking about a computer program, a computer, screen, or are we talking about a planet out there where they created this experiment, right? Which of the two is the platform? It says one thing that later generations might do with their super powerful computers is run detailed simulations of their forebears or people like their forebears. And then he says the great thing here. Suppose that these simulated people are conscious. Okay, now we're talking about Bugs Bunny gaining consciousness here. Okay, that's the context here. And he says, as they would be if the simulations were sufficiently fine-grained and if a certain quite widely accepted position in the philosophy of mind is correct. Well, I don't know about philosophy of mind. These must be retarded people in an asylum who believe that, that a cartoon gains consciousness. But if this is what a lot of these philosophers of mind think, well, they should all be institutionalized, period. These people have lost touch with reality. It says, then it could be the case that the vast majority of minds like ours do not belong to the original race, but rather to people simulated by the advanced descendants of an original race. It is then possible to argue that, if this were the case, we would be rational to think that we are likely among the simulated minds rather than among the original biological ones. Therefore, if we don't think that we are currently living in a computer simulation, we are not entitled to believe that we will have descendants who will run lots of simulations of their forebears. Okay, so this is his line of reasoning, if you can call it reasoning at all. I mean, these people need to be institutionalized. What can I say? They're not even, they lost touch with reality. How do we analyze this? Well, I have to begin by defining an important term here, and it's the word idiot. Okay, the word idiot comes from the old Klingon language, ancient Klingon language. Means big ideas. So, regular people, normal people who have their feet on the ground, rational people, they have ideas. And these people have idiots, big ideas. So we call them idiots, or idiots for short. Okay? And yeah, Bostrom and Kurzweil, all these people, they're a bunch of idiots. That's what they are. I mean, these people have no place in science. And it doesn't stop with them. Here we have another fellow who is doing a lot to try to get us out of the planet. And like if all these people are not already floating in midair, but there's a fellow who's trying to get us out of the planet. His name is Elon Musk. And he's got this plan with his company. He's got a few $1 billion to spend on this. He's got a lot of investors also. It says by 2026 he plans to launch an uncrewed, I would say unscrewed maybe, uncrewed starship to Mars carrying a robot, some kind of bot, right? And okay, that's okay. That's, I guess, feasible. I have no problem with that. In fact, we've sent already the rovers over there, and they're running around the surface of Mars. I guess these robots would be a little more sophisticated. Fine. 2031, approximately, send a human mission to Mars, okay? And that's possible. I'm not saying it's not. Maybe it's a little early at 2031, but so they send 6-8 people to Mars, right? So they walk around. Hopefully the robots built something for them so that when they arrive, they say, okay, at least we have a place to stay, protected with oxygen tanks and whatever they need to live, okay? Hopefully the robots did the pre-work, right? Now we send the humans. Not sure why we would send the humans. I mean, why not just leave the robots, have the robots do everything? I guess they don't need air, right? They can breathe the CO2. Okay, whatever. Okay, so we send the humans out there, and then he says by 2040, approximately, these are very approximate numbers or just wishful thinking, right? Make a self-sustaining civilization on Mars. So we build a tiny city, a village, whatever you want to call it. And then by 2050, create a multi-planetary civilization with Mars serving as a backup for humanity in the face of potential threats on Earth. So we have problems on Earth, and instead of fixing them, let's just leave the Earth, and everybody who's left behind, I mean, I don't think they can take 8 billion people or more, which we'll have by then, I guess, right, to Mars. So I guess the few ships that go out, right, they escape, and they say, well, the hell with you over there on Earth. All of you suffer with all the problems you got there, climate change or whatever. And we're headed to Mars, okay? So a very small group goes to Mars, right? But yet, Elon Musk on the other side, right, he talks about the declining birth rates in the world. Every country in the world has declining birth rates. And it's like nobody noticed that. Nobody realizes that That's somewhat of a problem. And he does say, must increase the birth rate in aging societies. How do you do that? When you get the old folks to have children? Well, maybe if we hit the technological singularity, maybe we can get away with that. We can get grandpa to have kids. Okay? Or the grandmas. That'd be a little tougher. Okay? But he does say that if we don't do this, we're going to have economic and technological consequences, among them shortages in the workforce, which I think is completely irrational. Okay? Why? Because we're losing jobs right now. So if anything, jobs are being lost faster than people are being lost. So I think we shouldn't have a problem with the workforce. The problem will be for the workforce to find work. I think that's going to be the problem, because the jobs are going to be disappearing. We're only going to have service jobs, and within that, internet jobs, right? That's the future. And if you're not on the internet, well, then you won't have a job. Forget about manufacturing, forget about agriculture. Those are going to be taken over, among others, by bots, right? Okay, and here we support Elon Musk's worries, his prediction, his concerns, right? And yeah, humans are no longer producing consumers. That's one problem. And you can see that until these days, we've dropped down from 2.3, which was the highest point in 1963, all the way to today. We only have a 1.0 growth rate for the whole population of the world, okay? And it's just dropping. And by mid-century, it's supposed to reach zero population growth. In other words, one person is born, one person dies. We're going to tie the game. And so population will remain steady, okay? After which, the question is, are we going to have this situation? Are we going to have population drop to zero? And what you're staring at there is known as density-dependent birth rates. Okay, what happens at density-dependent birth rates is that as we move to the cities, we abandon the country, right? We abandon the villages and move to the big areas. More and more people looking for jobs primarily move to the cities. Once you're in the cities, you can't have children. And again, it's known as density-dependent birth rates. It's forbidden to have children in the cities for economic, cultural, and other reasons. Okay, so what does Elon Musk propose for Mars? I mean, which of these is true? I mean, here it is. Here's a breakdown. Okay, we're going to explore Mars. If we're exploring, we don't really need anything other than robots. So we don't need to send humans at all. We're just going to explore Mars, right? Are we going to terraform or colonize Mars? That takes a lot of effort, a lot of money, because humans are not just the same thing as robots. And so that's a problem, because now you have insurance issues, you have health issues, you have a lot of things that you don't have with the robots. And then the question is the goal to evacuate Earth? We go from this big planet to this small planet known as Mars, where we have to terraform. In other words, until we terraform it, we change the CO2 into O2 so that we can breathe it. And we won't have the same pressure as here on Earth, because there's going to be less oxygen in the best of cases, right? All that granted. Are we going to live in little bubble cities? All these bubble colonies, bubble villages? I mean, what's the plan? Are we going to evacuate Earth? Or are we going to just send prisoners out there? Evacuate the prisons, send them all out there and say, hey, we don't want you here, go to Mars. Live as best as you can out there. So, we have to find out what the goal is, because if we don't have a clear-cut goal, big goal, I mean, we're just going to colonize, or we're going to just explore, we don't need humans if we're going to explore. And if we're going to evacuate the Earth, well, good luck with that one, right? Okay, so where does all this simulation theory come from? Well, how did he come up with this? And a lot of it has to do with this duality which we've had since as long as we can remember, which is the separation between soul and body, conscience and your body, your structure, right? The object and the concept. And here it is. Nick Bostrom tells you a common assumption in the philosophy of mind, again, all these philosophers, right, is that of substrate independence. What is a substrate independence? Well, it's the separation between, conscience and body, right? Like they were two separate things. It says the idea is that mental states can supervene on any of a broad class of physical substrates. Provided a system implements the right sort of computational structures and processes, it can be associated with consciousness experiences. And then he says the big bomb he throws in there. He says, it is not an essential property of consciousness that it is implemented on carbon-based biological neural networks inside a cranium. Silicon-based processors inside a computer could in principle do the trick as well. And he says, a computer that runs a suitable program would be conscious. That's where he says it all. I mean, he thinks that computers think. And a lot of people think like he does, that computers really do think. And they compare it against the thinking that humans have, with actual Mother Nature neurons, right? And synapses, right? He says it would be sufficient for the separation, for the generation of subjective experiences that the computational processes of a human brain are structurally replicated in suitably fine-grained detail, such as on the level of individual synapses. This attenuated version of substrate independence is quite widely accepted. Widely accepted by whom? By the mental patients at the asylum? I mean, who's accepting this? Who are these philosophers, so-called philosophers? Is this what they deal with every day? Is this what we're paying them for, to think about this nonsense? And this is so scary. Really, it is scary. What are these substance dualists? Well, here you have a quick breakdown, okay? So substance dualists typically argue that the mind and the body are composed of what? Different substances. And that the mind is a thinking thing that lacks the usual attributes of what? Physical objects. Size, shape, location, solidity, motion, adherence to the laws of physics, and so on. And yeah, what these people are proposing is that these substance dualists, right, is that the mind is a different kind of substance, a different type of thing, a different type of object. And again, this is the problem we have in science in general, right? And this is for the last 10,000 years, is no one defines the terms. No one defines the terms, and we don't have any idea what these people are talking about. No, the mind is not a substance, it's not a thing, it's not an object, okay? So don't call it a thing until you define the word thing. What is a thing? And this shows the importance of defining the word things, especially for the purposes of physics, because they are bringing this stuff into physics by saying that conscious is a thing. Only physics deals with things. Philosophy doesn't deal with things, okay? When you define philosophy properly, right? Not the way these people define it, which is undefined, really. They only have opinions. No, we need a definition of the word philosophy, and when you define philosophy as behavior, then obviously we remove all things, all objects out of there and put them into physics. These people are saying that consciousness would go to physics because it's a thing. And for that, you have to define what a thing is. Okay? And even under the current definition, that people use, the informal one that mathematicians use, which is see touch, you can't see or touch consciousness. So even there it fails under that definition, let alone under the shape definition. And so, yeah, these people have these notions that the body and the mind are two different things. The spirit, it goes to heaven, right? So we have this spirit that looks like you, has the same shape as you, and that's why they think it's a thing, maybe. And so, yeah, we have a problem because these people are treating this consciousness, this mind, this thinking, as being a physical entity that looks like you, leaves your body, right? Goes to heaven or wherever, in the case of these philosophers of mind. And because it can move, out of your body, it's a thing. but then they never define as a thing. They say, no, it doesn't have the properties of a thing, whatever a thing has, as attributes or properties. And so they never specify that because they would lose the game immediately, right? And my son always suggests, hey, they should program all this stuff. Put it in a program, quantum mechanics, general relativity, string theory. Put it in a computer program. See if the program can make sense of it. Define every entity that you're going to use for your theories and see what the computer program does. Will it handle it? Can it handle, space-time, for number lines? Can the computer program understand that and say, well, you're going to warp number lines, concepts? It's like warping love or intelligence. How do you do that? You can't warp concepts, and that's what space-time is. And so on with all this. Are you going to move consciousness? Well, first you got to define it as an object. And what is an object? Well, first you got to define it in a computer, and unless you define it properly, you will not be able to move it. So yeah, a lot of this stuff should be put in a computer to debunk the garbage of quantum mechanics and general relativity, string theory above all, but among other things, this notion that they have of simulation theory. It would die an instant death, and in retrospect, you would conclude that it should never have made it into the scientific literature. Okay, but there's another subject matter which is very closely related to this, and you should keep this in mind, and that's the holographic universe. Holographic universe is something invented by especially the string theorists, because you're asking a question. You're saying, look, all I want to know is why this pencil falls downwards. What causes gravity? What causes this pencil to fall downwards? That's the only question I want. A very simple question. You have an astronaut, he's flying to Earth. What's the system? Astronaut, Earth. That's the whole system. Very simple. It's baby stuff. It's kindergarten stuff. Do we need any math? Of course not. We don't need any math whatsoever. I want to know the cause. What causes the astronaut to fall to Earth? Or why doesn't the moon fly out of the solar system? What keeps it bound? What keeps it faithful to the Earth? Very simple question. Straightforward. And these people say, well, let me tell you about a black hole. It's got a singularity in the center, and at a certain radius, you'll find the event horizon, and all the matter that has fallen into the black hole, which apparently goes at the speed of light to the singularity, but somehow they preserve it in the body of the black hole, in other words, between the singularity and the event horizon. It's all there, and it's mapped onto the surface of this globular thing that encapsulates the singularity, known as the event horizon. And that's known as the holographic theory or hypothesis, whatever they want to call it. And they extrapolate that, and they say, look, the universe itself, our universe, right, is a hologram. And all the physical objects like planets, stars, atoms, gases, whatever, right, is mapped onto the surface of this ball, the event horizon of the universe, because I guess we live in some kind of black hole, right? And all this matter is somehow, instead of being spat out by Big Bang, I guess is falling to a singularity, which is where we started at the Big Bang, right? I don't know, which direction we're going. But the point is, it's mapped onto the surface of the event horizon of the universe. That's the notion these people have. And it's very much related to this other nonsense, the simulation theory. These people have lost their minds completely. They're no longer, with their feet on the ground. These are irrational individuals. And here you have a picture, famous picture that's out there about the holographic universe. It looks more or less like that. Again, this is just the Earth, but think of the Earth that you see there as the whole universe, right? Some kind of ball, Big Bang exploding, right? And it can be mapped onto a two-dimensional surface of some kind. That's what they're saying. And what's being mapped? the information. Information, they're mapping information. I mean, what does the word information have to do with physics? Are we going to move information? Are we going to transfer information? You know, in physics, it's very simple, or science really. Science is very simple. You don't transfer information. Okay? It's irrational to say you're going to transfer information, that you're going to transfer energy, that you're going to vibrate a field, that you're going to bend time. All those are irrational statements. And no, it's not semantic, it's not word salad. They're doing word salad. Okay? Whenever they give you a theory that says that time is warped, or that they transferred energy, or they, vibrated the field, they're giving you an irrational explanation. Okay? And so what's the issue? Well, the issue is here you have the you have this information, and they say they transfer information. You can't. Information is always on the receiving end. What the guy sends is the Morse code. He sends a signal through a wire, right? And that signal is transformed into some kind of dot. And the guy on the receiving end, for him, it's information. He says, oh, SOS, he needs help. So information is what the receiver gets. And he doesn't get it. He just analyzes what the machine translated. But you don't send information. Okay? But these people are talking about sending information and mapping information onto a two-dimensional surface. Whatever that means. What information? What are we talking about? Okay? And here we start with this fellow. His name is Matt O'Dowd. He's, on PBS. I call it BS. I leave out the P. I don't think it's necessary. It's just BS. And one of the things that Matt O'Dowd does, he starts talking about this, but he starts out on the wrong foot. And again, it shows the importance of defining terminology. What the hell are you talking about? And here he starts his presentation by defining what dimension is, what a dimension is. And he misses the mark altogether. It shows that he's not a physicist. He never studied physics in his life. And so listen to him make a fool of himself trying to define what a dimension is.
We live in a universe with 3 dimensions of space and 1 of time. Up, down, left, right, forward, back, and past and future. 3 plus 1 dimensions. What is a dimension but a number line of possible values which A. exists alongside the other dimensions but is independent of them, B. over which the rules of physics stay the same, and C. imposes some kind of locality. For example, elements of that number line need to be next to each other to interact. Crudely, this is how an extra dimension can be coded in a holographic universe.
Okay, so you got one right. They're not talking about dimensions, they're talking about number lines. But, he needs to learn the basics. I mean, front and back, left, right, down, those are not dimensions. Those are motions, and or locations. And they have nothing to do with dimensions at all. Here are the dimensions for him to understand, okay? The dimensions are 3, and there are only 3, and it's length, width, and height. Okay, you're going to talk about coordinates, you're talking about longitude, altitude, and latitude. And if you're talking about vectors, you're talking about depth, breadth, and elevation. Why? Because vectors deal with motion, coordinates with location, dimensions with orientation, and how you face, right? So all this are basic things that we learned our first day of physics. And this fellow talks about up, down, left, right, motions forward and backwards, and past and future, whatever that is, okay? So no, none of that has anything to do with physics or with dimensions. That's one issue. The other issue is that he did pick one, which hit one right on the nose, which is that, in math, all they have is number lines, okay? And number lines have magnitude but have no direction. They always put an arrow. It comes from this bean brain. His name was René Descartes. And he put an arrow at the end of number lines, and he called them dimensions or coordinates or whatever. In fact, they're known as Descartes coordinate system, right? No, they're not coordinates, okay? They're number lines, and you have to put numbers there, and numbers never have location. They can go in any order you want. You can put a number behind you, another one in front of you, another one to the side. Numbers don't have location, so you can't put them on a line with an arrow at the end of it and say, oh, numbers go in that direction. You know, that the fact that numbers increase in a given direction does not mean that they have direction. Direction has nothing to do with increasing numbers, okay? Increasing magnitudes. And so that's where they got confused, or they put it in there by hand. They said, look, numbers increase in that direction. No, they don't increase in that direction, or in that direction. Numbers increase in, the increase in numbers has nothing to do with direction. Okay, that's the first point. Okay, and so, this fellow just screwed that one up, and again, it's because they don't define their terms. Okay, but here he continues, and he talks about the information paradox, which is going to be like the first step in defining, this holographic universe. And here it is. Listen it from the horse's mouth. Here it is.
Stephen Hawking confirmed the Bekenstein bound by calculating the amount of information leaked by a black hole as it evaporates in Hawking radiation. His discovery of Hawking radiation led to the black hole information paradox, because this radiation was expected to erase the quantum information of everything that fell into the black hole. But destroying quantum information would break the foundations of quantum mechanics, hence the paradox. This conundrum inspired Gerard 't Hooft to show that the information of all material that fell into the black hole could be imprinted on that outgoing Hawking radiation. And while it's waiting to be radiated, that information should be encoded on the event horizon of the black hole.
So these bean brains, what are they doing? They're talking about information now. And what information? And they say the information's encoded on the inside, or I guess on the outside of the event horizon. It's on the surface of the event horizon. It's part of the event horizon. And they start talking about this idiotic thing that Hawking invented, which is that, one particle falls in, the other one falls out, because quantum mechanics says that all particles have their opposite particles. And you have all these virtual particles, they break in two, one goes in, the other one goes out, and that's the one that comes out. And that's how they explain Hawking radiation, meaning comes out. And so this notion that originated the black hole, that, it doesn't emit light at all, they had to remove that because there was no work then for an astronomer to do. Says, well, I can't see a black hole because nothing comes out of it. They said, hey, yes, it does, all this Hawking radiation. But then they said, oh, hold it, but the Hawking radiation, if it comes out, that means you have all this information that's being crushed and disappears forever, and that destroys the second law of thermodynamics, so we can't do that, conservation of energy, all this other nonsense. And so what they said, look, we have an explanation for that, and that is that it doesn't come out with the Hawking radiation, it gets imprinted on the event horizon itself. That's how they figure this out. This is how they reasoned it out. All these people who you're paying their salaries to, to figure all this important stuff out. Okay, and here's how he explains it in a little more detail, how it's mapped on the 2D surface known as the event horizon. O'Dowd. Okay, so here it is.
Nice solution, but new paradox. Things that fall into a black hole do actually experience crossing the event horizon and being inside the black hole. So the interior of the black hole has a dual existence. From the point of view of outside observers, its contents are smeared into 2D on that surface, but from the POV of anyone falling in, they are definitely inside the black hole, plummeting to their doom in full 3D glory. This is the first glimpse of a holographic spacetime, a 2D surface that encodes the properties of the 3D interior. 't Hooft, along with Leonard Susskind, extrapolated this to propose that not only is any surface sufficient to describe the locations of all particles in its volume, but also the full machinery of that volume can exist on the surface.
Okay, so all the information, whatever information is, right, is encoded on the surface of the black hole. What's this got to do with physics? What's it got to do with anything? Assuming it's true, we're going to concede, right? What's it got to do with physics? Are we supposed to look at a black hole event horizon and figure out that whatever fell in? What is this information thingy that they're talking about? And the thing here is that Susskind got into a little war with Stephen Hawking on the issue, and he wrote a book, The Black Hole War, My Battle with Stephen Hawking to Make the World Safe for Quantum Mechanics. Okay, and again, it was just put Stephen Hawking in there so that he could sell books. That's the only purpose of this nonsense. They have this black hole war, and the question is, what's it got to do with science? Why would anyone buy such a stupid book that deals with such a ridiculous subject? And this is how the war started, more or less. Okay, the black hole war. These two mental pygmies, right? Hawking suggested that black holes do not just capture matter and energy, but also obliterate the information contained within them. According to classical general relativity, all the information about the material that fell into the black hole would be lost along with it, contradicting quantum mechanics' precept that information is conserved in physical processes. Information is conserved? What the hell are these people studying? These are physicists. They call themselves physicists, and they're talking about information. Susskind proposed that information, contrary to Hawking's assertion, is not lost in black hole, but rather somehow conserved. So we have information that is being conserved, I guess, in a little bottle, right? Susskind began to argue that there had to be a mechanism within the framework of physics that ensures informational continuity. Framework of physics. These people are saying that what they're talking about is physics. Is this physics? Does this information thinking have anything at all to do with physics? What are these people gaining their salaries on what basis? What are we paying them for? Okay, that's the question you should ask yourself. And here he says, came up with a holographic hypothesis, says the holographic principle emerged as a groundbreaking paradigm in theoretical physics, marking a significant shift in our understanding of the universe. The principle postulates that all the information contained within a volume of space can be represented as encoded on a boundary to that region, essentially suggesting that our three-dimensional world is a projection of two-dimensional data. This paradigm aligns with the way black hole entropy, which can be described by the area of the event horizon rather than the volume within, operates. Okay? So this is how black hole entropy operates. What is entropy? Just amount of disorder. And I'm not sure what these people are referring to, because everybody says out there that a black hole simply takes anything that crosses the event horizon, takes it directly to the singularity where it gets crushed out of existence. So how these people say that all this information is still somewhere in there and gets mapped onto the surface, I can imagine all the information on top of information on top of more information on the surface of the event horizon. Imagine putting all the information one on top of the other. What kind of information is that? And he says, he suggested that this information isn't lost, but rather remains encoded in a two-dimensional form, adhering to the principles of quantum mechanics. If the universe itself operates holographically, every part of our universe could be storing information about the rest of the universe. Again, he thinks that our universe is encapsulated in some kind of ball, sphere, whatever, right? And that if we go to the edge of space-time, right, or the Big Bang, or whatever you want to call it, which is where we're at right now anyways, because they say that, space-time expands and all the galaxies are on the surface of space-time. They just get farther apart because the balloon is expanding, right, like polka dots, right, on a balloon. And so we're on the surface. That means all the information is encoded where we're at. Okay, all we have to do is go all around space-time. We'll find all the information that we want. Travel around space-time, split second, I guess, right? Okay, does this have any value whatsoever in physics? Well, we begin by saying that there's no such thing as a black hole. So if there's no such thing as a black hole, if a black hole is nonsense invented by the idiots, idiot, what is an idiot? Person with big ideas, right, of math. If there's no such thing, then all these people are wasting not only all their time developing these equations for absolute poppycock, for stuff that doesn't exist. Among them dark matter, dark energy, and so on. But how about the black hole? The black hole has been proven, right, beyond reasonable doubt, right? Has it been proven? Well, here it is. Here's the black hole. What is a black hole? Well, let's find out. Okay, black hole is simply a star that collapsed according to mathematics, right? It's a star that has collapsed gravitationally upon itself. Okay, so it crunches all the atoms that made up the star to the point where they all get crushed out of existence. They get all crushed out of existence. What is left is a concept, an abstract concept, which is comprised of two concepts. One is the singularity, which is the center of this thingy called the black hole, and its encapsulating cover, membrane, I guess, I don't know. It's a concept and known as the event horizon. And there you see it. That's it. Dot in the center, covered by a concept known as the event horizon. Is this a physical object? Well, again, you would have to define what a physical object is for the purpose of physics to qualify a black hole as an object, as a thing. This is not a thing. This is a concept. Okay? And concepts are totally different than things. Okay? So this is where we start. This is what a black hole is, meaning so far we have nothing. We have a concept. And to add to this, we have the issue that if it's like they say that the black hole crushes all matter out of existence, it has no mass, because mass is the quantity of matter, or a measure of the quantity of matter. All matter has been crushed out of existence. We have zero matter. Guess how much mass we have? We have zero mass. So we have a concept that has zero mass. So far we have the definition of nothing. And that's what these people do. They study and make equations for absolutely nothing, literally. Okay, but let's concede. Okay, let's concede it's got mass, runaway mass, infinite mass, whatever you want to call it. I don't care. Put as much mass as you want inside a black hole. Okay, here it is. Okay, how does those kilograms, which is what mass is, right? Kilograms, how do they affect a star far away? That's billions of miles away. How does it flay the skin of the star alive, right? How does it force the star to move around the black hole? I mean, how do kilograms do it? I want to know the mechanism, right? And you could argue that it's done somewhat like this, where, the kilograms push downwards on space-time, which is the notion they have. So we have this infinite deep hole, right? And somehow that fishnet reaches all the way to the sun, to that star, right? And moves it around. But then how does this process flay the skin off of that star? I mean, do the gas molecules just roll along the fishnet to the black hole? Is that how it's done? I mean, what's the process? What's the mechanism? How do kilograms do these things? And of course, if the kilograms weigh the space-time downwards, we have Newtonian gravity. You have to explain why how the kilograms do that. And of course, they can't do that without invoking good old Newton. So, when they came up with this more accurate, as they call it, more precise equation, Newton's equation, trouncing Newton's equation, it turns out that in order to give their explanation, they have to bring Newton back. And they say, look, the sun weighs the canvas downwards, right? It should be really the other way around. The canvas should go downwards for whatever reason, and the sun has no other course but to fall into the hole, because it, the whole thing caved underneath it. But the way they explain it is in reverse. They say the sun, the mass of the sun, right? It's the mass, the kilograms, right? Push the canvas downwards. Could be upwards, but they always show it downwards because otherwise people would have too many questions. So it pushes the canvas downwards, right? And now that it pushed it downwards, the question then pops, why did it push it downwards? What forced the sun, the kilograms, right, to push the canvas downwards? Was there gravity pulling downwards, or was it kilograms pushing it? Which of the two is true? And so they never answer those questions. They just say, well, it just happens. That's the explanation for Einstein's equation, and that's the end of it. Don't ask more questions, right? And so, yeah, when you look at it, all these people like, Susskind and Ed Witten, what they're doing is they say, oh, these celebrities, these great mathematicians, they're such great minds. And, mind is a terrible thing to waste, because what these idiots are doing is developing equations for inexistent stuff. And that's what they do all day. And you're paying them to do that. So, yeah, I like to put this in this context that, they're developing equations for dark unicorns and black leprechauns. That's what these people are doing. They develop all these equations, and they say, look, we're doing science. This is not science. This is garbage. This is poppycock. It's got nothing to do with physics or with science. And the first thing that they should really do is show that there is such a thing as a black hole. And for that, they would have to define the word thing first, so we know what they're talking about when they say the word thing or object or whatever, right? Entity. Once they have that definition, then we can talk about things and determine whether a black hole qualifies as a thing. What is a black hole? A singularity, which is a concept, infinity, right? Where the laws of physics break down, whatever that means. And it's surrounded by an event horizon, which is a concept, which is like, the fire in a campfire. It's how far the heat reaches, right? And that's the surface of heat from the campfire, and that's more or less what an event horizon is. It's a surface of gravity surrounding the singularity, which is a point of infinite density, whatever that means, meaning it's zero-dimensional. And if it's zero-dimensional, it means all black holes are the same size because they all have infinite density. And it turns out that there's no mass in there because it crushed all matter out of existence, and mass is the quantity of matter. So we have the definition of nothing. And that's what all these people are working on. They're developing equations for absolutely nothing. I'll see you next week.